In this problem of trigonometric identities, on the left hand side I have cosine a raised to the power of 4 plus sine a raised to the power of 4 and divided by cosine a raised to the power of 4 minus sine a raised to the power of 4. And on the right hand side I have 1 upon 2 times cosine of 2a plus secant of 2a. So in order to prove this identity, I am going to prove the left hand side onto the right hand side. And on the left hand side, if you look, there are two types of trigonometric functions over here. First, I have this cosine a raised to the power of 4 and I have sine a raised to the power of 4. So the two types of trigonometric functions on the left hand side are cosine a raised to the power of 4 and sine a raised to the power of 4. And on the right hand side, the two types of trigonometric functions are cosine of 2a and secant of 2a. So cosine of 2a and secant of 2a. And if I want to prove the left hand side onto the right hand side, means I need to convert these trigonometric functions into these trigonometric functions. And the difference between these two is that first of all my angle is changing from a and going up to 2a. So my angle is going from a to 2a. So my angle is getting increased. And on the left hand side, the power, the trigonometric function was raised to the whole power of 4. So my power is going from 4 and going up to 1 because there is no power here, so the power is 1. So my power is getting decreased. And if I look at my formulas, whenever there is a case of angle is getting increased or decreased and the power is getting decreased or increased, we use these formulas, these double angle formulas of cosine of 2a. So if I rewrite my formulas over here, the first formula is cosine of 2 theta is equal to 2 cosine square theta minus 1, and the second is cosine of 2 theta is equal to 1 minus 2 sine square theta. In both of these formulas, on the left hand side I have 2 theta. So the angle is 2 theta and the angle is going up to theta. So the angle is changing from 2 theta to theta. So the angle is getting decreased. And the power, if you look on the left hand side, the power is 1. And on the right hand side, the power on the trigonometric function is 2. So the power is going from 1 up to 2. So my power is getting increased. But I want the opposite. I want the angle to increase and the power to decrease. So in both of these formulas, I am going to make sine square theta the subject and cosine square theta the subject. So if I make sine square theta the subject in this formula, this would become 2 sine square theta is equal to 1 minus cosine 2 theta. And after I divide both sides by 2, it would become sine square theta is equal to 1 minus cosine 2 theta divided by 2. So now the power is going from 2 to 1, so the power is getting decreased and the angle is going from theta up to 2 theta, so the angle is getting increased. And that's what I want. I want the angle to increase and the power to decrease. So this is my first formula, and I'm going to use this formula to replace sine a raised to the power of 4. Similarly, to replace cosine a raised to the power of 4, I'm going to make cosine square theta the subject in this equation. So after I make cosine square theta the subject, this would become 1 plus cosine of 2 theta divided by 2. Now let's use these formulas to prove the left hand side to the right hand side. On the left hand side, I have cosine a raised to the power of 4. And in order to use this formula, I'm going to write this cosine a raised to the power of 4 in terms of cosine square a. So I'm going to write this like this: cosine square a whole square plus sine square a whole square. If I were to remove the bracket, this 2 would come inside to get multiplied by this 2 and would eventually become sine a raised to the power of 4. So I can write this like this, and divided by cosine square a whole square minus sine square a whole square. Now in place of cosine square a and sine square a, I am going to substitute these two formulas, but the substitution of both of these two would make the question very complicated. So what I'm going to do for now, I am going to write my numerator. This is my numerator in the fraction and this is my denominator. For now I am going to write the numerator and the denominator separately, and at the end I am going to join the two by writing numerator upon denominator at the end. But for now I am writing the numerator separately. The numerator over here is this cosine square a whole squared plus sine square a whole squared. In place of cosine square a, I am going to substitute this 1 plus cosine 2 theta divided by 2. So this would become 1 plus cosine of 2a, because the angle over here is a instead of theta. So 1 plus cosine of 2a divided by 2, and plus, in place of sine square I am going to use this formula. So 1 minus cosine of 2a divided by 2, and whole square, this whole square here and this whole square here. Now if I were to take this power of 2 inside the bracket, this 2 would go on to this whole numerator. So this would become 1 plus cosine of 2a whole square divided by 2 square, which is 4, and plus this would become 1 minus cosine of 2a whole square divided by 2 square, which is 4. Now in both of these fractions the denominator is the same and they are getting added. So I can write this expression like this. The denominator is 4 and 1 plus cosine of 2a whole squared plus 1 minus cosine of 2a whole squared. Now I'm going to expand both of these brackets. The expansion of this bracket using the formula of a plus b whole square is going to be a square plus 2ab plus b square. A over here is 1 and b is cosine of 2a. So the expansion of this bracket would give me 1 square, which is 1, plus 2 times 1 times cosine of 2a, so 2 times cosine of 2a plus cosine square of 2a. This was the expansion of this bracket, and the expansion of this would give me 1 minus 2 times cosine of 2a plus cosine square of 2a, and divided by 4. This 2 cosine of 2a and this 2 cosine of 2a cancel each other out, and 1 plus 1 is 2, and cosine square 2a plus cosine square 2a is 2 cosine square 2a. So I am going to write this 2 plus 2 cosine square of 2a divided by 4. And if I take 2 common in the numerator would be 1 plus cosine square 2a divided by 4, and this 2 and this 4 cancel out, so I'll get 1 plus cosine square 2a divided by 2. This is the simplification of this numerator. Now after simplifying the numerator like I did over here, I'll simplify the denominator now. The denominator is cosine a squared minus sine squared a whole squared. So cosine square a whole squared minus sine square a whole squared. This expression over here is in the form of a square minus b square, where a is cosine square a and b is sine square a. And whenever we have any expression in the form of a square minus b square, we can write that in the form of a plus b times a minus b. So I'll write this denominator in this form. So this becomes cosine square a plus sine square a and cosine square a minus sine square a. Cosine square a plus sine square a, if I look at my first Pythagorean identity, if sine square theta plus cosine square theta, that equals to 1. So this whole goes to 1, and this is cosine square a minus sine square a. And for this I look at this formula, cosine square theta minus sine square theta is equal to cosine 2 theta. So this would be equal to cosine of 2a, and cosine of 2a times 1 is just cosine of 2a. So this is the simplification of my denominator. This was my denominator, and I simplified it into cosine of 2a. So now I'll write my numerator, which was simplified into this. I'll write this again in my fraction form, numerator upon denominator. Numerator was simplified into 1 plus cosine squared of 2a divided by 2, and my denominator is cosine of 2a. And now I need to simplify this further so that I can show this in this form on the right hand side. So if I make some space again, and this fraction is same as saying 1 plus cosine square of 2a divided by 2 times 1 upon cosine of 2a. And when this 2 gets multiplied by this cosine 2a, this becomes 1 plus cosine square of 2a divided by 2 cosine of 2a. And if you look on the right hand side, I had 1 upon 2 outside of the bracket. It was taken as a common. So if I take this 2 in the denominator common, this would become 1 upon 2 times 1 plus cosine square of 2a divided by cosine of 2a. And now I'll break this fraction even further. I'll write 1 with the denominator of cosine of 2a, and I'll write cosine square of 2a with the denominator of cosine 2a. So 1 upon 2 times 1 upon cosine of 2a plus cosine square of 2a divided by cosine 2a. This cosine 2a cancels 1 cosine 2a from the denominator. So 1 upon 2 times, and over here plus cosine of 2a. And for this 1 upon cosine of 2a, I'll use this identity. 1 upon cosine theta can be written as secant of theta. So I'll write this as secant of 2a. And this was the expression on the right hand side. Secant of 2a plus cosine of 2a can be written as cosine of 2a plus secant of 2a. So it's the same thing. So I have proved my identity.